All right, and welcome to the third video in our series here, moving right along in Intro to Science. This video, all about scientific notation. What is scientific notation? It's basically an abbreviation for numbers. Really big numbers or really small numbers. So the same as you would use an abbreviation to make a word shorter, you would do this scientific notation to make numbers shorter. And we would do it for a number like this one. This number is outrageously large. In fact, it's beyond what most of us know how to do when we start to count things. So like that's hundreds, that's thousands, millions, billions, trillions, and then we get well beyond what any of us really memorize for calling out a number. Plus, if I write this, I don't want to write this every time. That takes way too long to write all of those zeros. So scientific notation allows me to write it in a shorter fashion. I would be able to write it as simply 3.75, that's pertinent, times 10 to the something. We'll figure that out here in just a second. So in scientific notation, we're basically making an abbreviation of a number. In order to do scientific notation, you have to follow a couple of simple rules. Hopefully this isn't difficult. The first thing we got to do is we have to find your decimal. That shouldn't be a problem if the number already has a decimal in it, but if you're not familiar with a lot of math, any whole number like this one right here has its decimal sitting behind the last zero. Also important to remember, behind that decimal and in front of the last whole number, like the 3, you have an infinite number of zeros. So we can move that decimal up or down, just multiplying by 10 in order to move it however we need. Now, if we're looking at that number right there, then we're going to have to take our decimal, like that right there, and we're going to have to count across how many times we need to move our decimal past the different zeros. Now, pay attention, because this is something that I'm not writing out, but it's going to be an answer to one of your quiz questions following the video. I always want you to move the decimal behind only one whole non-zero number. So that means we're not going to move the decimal until we get behind the 4. We're going to move it until we get behind the 3, because it needs to be sitting behind a whole non-zero number. All right, that's not going to be written, but it is going to be on the quiz. So we move it 1, 2, 3, 4, 5, 6 spots. That 6 spots is what we move to move that decimal behind one whole non-zero number. Now, remember that 6, and then we're going to rewrite the number with a times 10 to the nth power. That n power is just the number of spots we moved the zero, or moved the decimal across zeros, okay? So in this case, we moved it 6 times, and we would rewrite it as 3.4, then times 10 to the 6, because we moved it 6. Now, it's very important to remember that this can be done with both very large numbers or very small numbers. For instance, this number right here is a very small number, but still a lot of wasted zeros. So again, they move that decimal back, and they move it back based on how many zeros they need to go behind until it sits behind one non-zero whole number. They moved it back 9 times, in fact. So then they rewrite it as 4.56 times 10 to the, now they moved this to make it smaller. They moved it to the right, so they made it -9. And that's all you have to do in order to figure out how to do scientific notation. Now, before we actually have some work material that you'll be graded on, I'm going to give you an opportunity to practice a little bit of some easier scientific notation. Here's 6 different problems you have. I went ahead and counted the zeros for some of the bigger ones, so you don't have to worry about, oh my goodness, how many zeros is that, when you're just looking at something on a computer screen. What I want you to do is I want you to try to solve these. Pause the video at this point in just a second and try to solve all 6 of them. Then you can go ahead and go to the next part of the video where I'll show you the correct answer, and then I'll even show you how I solved each of them so that we can figure out how to do this together. Go ahead, pause it now. Okay, here's all the correct answers in blue over here for each one of the problems. Did you get these correct? I hope you did. But if you didn't, let me show you how to do it real quick. All right, in number 1, this is 98,000. Our decimal point starts right there. We're going to move that decimal point 1, 2, 3, 4 spots. After we moved it 4 spots, we just rewrite it as 9.8 times 10, and then we moved it 1, 2, 3, 4 spots. We moved it forward and it was positive, so that's 10 to the 4th power. See how that works? The second one, we did the same thing except we already had the decimal spot, so we just moved it back 1, 2. That's going to give us 8.5 times 10. We moved it backwards, so it's negative 2. That next one, our decimal spot is again going to be behind the last 0. I told you that it's 9 zeros, so we know we're moving in at least 9 spots, but then I want it in between the 8 and the 5, so it's only behind one whole non-zero number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we write 8.5 times 10 to the, we moved it forward, so 10 is positive power. Next up, we already have the decimal there. We're going to move it back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 past the zeros, but it also needs to be behind the 1. So we're going to move it back 12 spots. Then we just have a 1. Well, that's easy to write. 1 times 10. We moved it negatively, so we're going to move it to the negative, and then 12 times. All right? Now, this next one's kind of silly because, hey, why would we even bother to make 12 shorter? We actually make it longer by doing it. You probably wouldn't, but this is just for the sake of experimenting around to make sure you know how to do this properly. In this case, I can see very clearly that my decimal is behind 2. I'm going to move it 1 spot forward, and I'm going to have 1.2 times 10. I moved it positively, so to the 1 power. All right. And that leaves us with just the last one with the most zeros, but it's exactly done the same way as all the others. So we know that there's a decimal right there. We have 13 zeros, so we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. But then we're not going to stop there. We're going to move it 14, 15, 16 times so that we have 1.458. You need all of your non-zero numbers times 10 to the, we moved it positively, and we moved it 16 times total. That's how it's done. Now you try.